So let's take a look at a coordinate geometry of the circle question from the Leaving Cert Ordinary Level 2014 paper 2. So it's question 3, and the first question gives us the equation of a circle, x plus 2 squared plus y minus 3 squared equals 100. And we're asked to write down the coordinates of A, the centre of the circle, and R, the radius length. So in our tables we have the formula for the equation of a circle, x minus h squared plus y minus k squared equals r squared, where hk is the centre of the circle and r is the radius. So if we write down our circle, x plus 2 squared plus y minus 3 squared equals 100, we can get the radius by changing the signs of the terms in the brackets. So our centre is minus 2 plus 3. And we can get the radius by finding the square root of 100. And the square root of 100 is 10. So the second part of the question asks us to show that the point P minus 8, 11 is on our circle, x plus 2 squared plus y minus 3 squared equals 100. Any point is either outside of the circle, on the circle, or inside of the circle. And to find out which, we're going to sub in minus 8, 11 for x and y into our equation. If the left-hand side is less than 100, the point is inside the circle. If the left-hand side is equal to 100, it's on the circle. And if the left-hand side is greater than 100, it's outside the circle. So subbing in minus 8 for x and 11 for y, we get minus 8 plus 2 squared plus 11 minus 3 squared is equal to 100. Minus 8 plus 2 is minus 6. 11 minus 3 is 8. Minus 6 squared is 36. 8 squared is 64. And 36 and 64 is indeed 100, which shows that the point P minus 8, 11 is on the circle. For part B, we're asked to find the slope of the radius AP. It's always useful to draw a sketch of the circle. This only has to be a rough sketch. So we know that the centre is minus 2, 3. And we know that the point P minus 8, 11 is a point on the circle from A part 2. We're interested in the slope of the radius connecting A and P. The formula in our tables for the slope, m equals y2 minus y1 over x2 minus x1, requires 2 points, which we have, A and P. So we're going to label A minus 2, 3, x1, y1, and we're going to label P minus 8, 11, x2, y2. And we're going to sub these into our slope formula. So the slope becomes m is equal to 11 minus 3 over minus 8 minus minus 2. 11 minus 3 is 8, and minus 8 minus minus 2 is plus 2, so minus 8 plus 2 is equal to minus 6. We can divide the top and the bottom by minus 2 to simplify the fraction, and we get the slope of the radius AP is minus 4 over 3. Part 2 asks us to find the equation of the tangent T, the tangent to C at the point P. So a tangent is just a line that touches a circle at one point, in this case the point minus 8, 11. So we're using the equation of a line formula, remembering that a tangent is just a line. We need two things to use this formula. We need a point x1, y1, which will be minus 8, 11. And we also need a slope m. We don't have the slope of our tangent, but we have the slope of AP, a perpendicular line to the tangent from P back to the centre, which is minus 4 over 3. If we have a slope and we're interested in finding the perpendicular slope, we invert the slope, turn it upside down, and change the sign. So a perpendicular slope to minus 4 over 3 is the slope 3 over 4. And so the slope of our tangent is 3 over 4. So we have the slope of the tangent, 3 over 4, and we have a point on the tangent, minus 8, 11. If we sub these into the equation of a line formula, we get y minus y1, which is 11, equals our slope, which is 3 over 4, on x minus x1, which is minus 8. If we multiply both sides by 4, we get rid of the fraction. So on the left hand side we have 4 on y minus 11 equals 3 on x, and minus minus 8 is plus 8. We'll multiply out the brackets to simplify. 4 by y is 4y. 4 by minus 11 is minus 44 equals 3 times x is 3x, and 3 times 8 is 24. We're going to bring all the terms to the left hand side, so we're going to subtract the 3x from both sides. So minus 3x plus 4y minus 44. We'll subtract 24 from both sides, so minus 24 is equal to 0. We'll simplify the number terms, so minus 3x plus 4y minus 68 equals 0. And an optional step is to multiply across by minus 1 so that our x term is positive. So 3x minus 4y plus 68 equals 0. And this is the equation of the tangent to the circle C at the point P minus 811. In part C of the question, we're told that there's a second line K, a tangent to C at the point Q, and they tell us that K is parallel to T. So when we see two vertical lines like this, that just means parallel. So a sketch is very important for a question like this. We can see that if K is parallel to T, that it looks like this, and Q seems to be at this point here, the point of tangency. To find Q, we can do a translation. We know that it's the same distance from the center as is the point P minus 811. So Q is going to be the image of the point P through symmetry in A. So if we look at the translation from P to A, we can see that the x coordinate went from minus 8 to minus 2, so up 6 units. And we can see that the y coordinate went from 11 to 3, down 8 units. So if we take the point A and we move the x value up 6 units and the y value down 8 units, we'll have the point Q. So minus 2 plus 6 is 4, and 3 minus 8 is minus 5. And so the point Q is 4 minus 5.